Welcome back to our course series on the evolution, technologies, and business applications of artificial intelligence. I'm Dr. Shan Shui, and in this lesson, we will continue by exploring another important topic in AI. Let's begin. If you look at the title of the slide, Lesson 2's focus is on levels and types of AI. In other words, we are not just asking what AI is animal. Now, we are asking how intelligent is AI? What kinds of AI exist? And how should we classify them in business practice? So today's lesson will help us move from a general understanding of AI to a more structured way of distinguishing different forms of intelligence, capability, and application. Let's begin. So let's start with the objective of today's lesson. This slide gives us two core learning goals. First, we want to learn how to distinguish different types of AI. And second, we want to clearly understand the difference between RPA and AI. Because in business practice, these two are often confused. That distinction is extremely important. Many companies say they are doing AI, but sometimes what they really mean is process automation. So by the end of this lesson, I want you to be able to look at a system and ask, is this actually learning and making predictions? Or is it simply following rules? This is our roadmap for today. If you read down the slide, you can see that we will move through 5 parts. We begin with weak AI versus strong AI, because that is the broadest distinction. Then we move to the 4 levels of intelligence in service AI, which give us a more refined business framework. After that, we examine the functional technology classification, especially the shift from analytical to generative AI. Then we clarify the boundary between RPA and AI. Finally, we close with summary and discussion. So this lesson gradually moves from big picture ideas to practical decision rules. Now, let's begin with the first big distinction: weak AI versus strong AI. Even if the text on the slide is simple, the contrast is powerful. You can think of this slide as pressing AI on a line between reality and dream. That is the right way to frame the discussion. In the media, AI is often presented as if it is moving rapidly toward human-like, all-purpose intelligence. But in reality, most of the AI systems that create value today are still highly specialized. So this section is really about separating what exists now for what people imagine for the future. So let's talk about weak AI first. Please look carefully at the images on this slide At the top, you see a assistant playing Gomoku. In the middle, you see a recommendation interface like Netflix. At the bottom, you see a warehouse robot. These three examples look very different, but they all illustrate the same concept, narrow AI. This is why the text on the right side matters. Domain-specific and the current business mainstream. Weak AI or narrow AI is not weak in the everyday sense. It is often extremely powerful, but only within a specific task domain. A Gomoku playing AI can beat words campaign, but it cannot suddenly become a doctor, a lawyer, or a marketing strategist. A recommendation engine can predict what you might want to watch, but it cannot manage a supply chain unless it is specifically trained for that purpose. So the key idea here is specialization. Most commercial AI today is powerful because it is narrow. Now, compare that with the last slide. Here, the visual changed dramatically. Instead of concrete business application, we now see a growing brain image. This is a strong signal that this slide is talking about something broader and more hypothetical, artificial general intelligence, or AGI. Please focus on the phrase at the bottom. Cross-domain adaptability, context awareness, and the ability to understand and perform many tasks. This is the dream of strong AI, not just solving one task extremely well, but transferring knowledge across domains the way humans do. This is why strong AI is so fascinating. It refers to a system with a more general, flexible, human-like intelligence, but it is also why strong AI remains mostly theoretical. We do not yet have machines that can truly move across domains with the same adaptability and deep understanding that humans have. This is one of my favorite business slides in the deck because the two images tell the story very clearly. On the left, we see a person standing on a mountain path, looking toward distant peaks. That image represents vision, the long-term ambition of AGI. On the right, we see a vault-like image, suggesting value, protection, and business return. That image represents reality. The fact that narrow AI is already delivering enormous economic value today. And the bullet points at the bottom make the point explicit. We do not need machines to be conscious. We only need them to outperform humans in specific tasks. So from a managerial perspective, this slide teaches us an important lesson. Companies may dream about AGI, but they compete and profit through specialized AI systems right now. Now, we move into the second major part of the lesson. Please look at the figure on the slide. You can see a staircase moving upward over time. On the vertical axis is intelligence, and on the horizontal axis is time. This means the framework is not just classifying AI types, it is also suggesting a developmental progression. According to Huang Rust, AI in service evolves through 4 levels: mechanical, analytical, intuitive, and empathetic. So instead of asking only whether AI is weak or strong, this framework asks a more business-oriented question. What kind of intelligence is the system demonstrating? And what kind of service task can it support? That makes this framework especially useful for managers, marketers, and service designers. Now, let's begin with the first level, mechanical AI. Look at the 3 images here. A self-service kiosk, a warehouse robot, and an automated checkout gate. These examples are visually perfect for this level because they all emphasize routine action. Nothing here requires deep reasoning or creativity. What matters is standardization, repetition, and consistency. Exactly the key word shows at the bottom of the slide. Mechanical AI is the layer of automation. It is useful when tasks are repetitive, rule-based, and highly structured. In business, its value comes from reliability and efficiency. Machines do not get tired, distracted, or emotionally inconsistent. They just keep performing the same task at a stable level. Next, we move on to another level, to analytical AI. Visually, this slide shifts from machines doing repetitive physical tasks to a system processing information. We see dashboards, a recommendation interface, and data-driven screens. These images help us immediately understand the nature of analytical AI. This is the level when AI starts learning from data, identifying patterns, and making predictions. So when you look at the keywords, data-driven, logical prediction, and machine learning, you can think of this level as the computational brain of modern business AI. This is where many high-value business applications live. Forecasting, credit scoring, recommendation systems, churn prediction, and operational analytics. Analytical AI is not mainly about creating new content. It is about helping organizations make better judgments from large amounts of data. Now, we move into a more advanced level, Intuitive AI Level 3. Please look at the images. On the left, we see a Gomoku praying robot, which immediately reminds us of AlphaGo. In the middle, we see medical imaging interpretation. On the right, we see a professional reviewing documents, suggesting legal or expert judgment. These are not simple, repetitive tasks, and they are not only about clear numerical prediction. They involve contextual understanding and complex problem solving. That is why the phrase, the expert with insight, is so effective here. Intuitive AI refers to systems that can handle ambiguity better, detect patterns in complex situations, and support decisions that look more like expert intuition than simple automation. Now, we come to the highest and most difficult level in this framework, Empathetic AI. This slide is visually rich. On the left, we see a therapeutic robot. In the center, we see the movie Her, which immediately evolves the idea of emotionally engaging AI. On the right, we see emotion detection software analyze facial expressions. Together, these images help us understanding that this level is not just about information processing. It is about emotion recognition, social interaction, and high-touch service. But notice the question mark in the title. A soul with emotion? That question mark is important. It reminds us that this is still a frontier. AI can simulate emotional response and detect emotional cues, but genuine empathy is still deeply human. Okay, this slide brings us back to the full staircase, and now it should look much clearer than it did before. The first time we saw the figure, it was an introduction. Now, it becomes a summary. As you look from left to right, you can see the progression from mechanical execution to data analysis to contextual judgment and finally to emotional interaction. So this framework does more than classify AI. It also helps us think strategically. It tells us where a company is currently using AI, where it might move next, and which human capabilities remain especially valuable. So we shift to a different kind of classification. This slide is visually structured as a comparison between two perspectives. On the left, we have the engineer's perspective. Discriminative models versus generative models. On the right, we have the manager's perspective. Analytical AI versus generative AI. The arrow in the middle is important because it tells us these are related ways of viewing similar underlying distinctions. So this slide is essentially translating between two languages, the language of technical AI and the language of business application. So first, let's discuss about the discriminative AI, or we can call it analytical AI. This is a very visually intuitive slide. If you look at the image, you see red dots on one side and blue dots on the other, separated by a boundary line. That image captures the essence of discriminative or analytical AI almost perfectly. This type of AI learns how to distinguish categories, classify inputs, and predict likely outcomes. It does not create new examples of the words. Instead, it learns where the boundaries are. Is this spam or not spam? Fraudulent or legitimate? High risk or low risk? Will this customer churn or stay? So when you see the three words at the bottom, distinguish, classify, predict. That is the entire logic of analytical AI or discriminative AI in one line. Now, compare the slide with the previous one. Instead of a boundary between classes, we now see a face emerging from noise. That visual is excellent because it shows us that generative AI does something fundamental different. It does not simply separate categories. It learns patterns so deeply that it can create or simulate new outputs. That is why the text at the bottom says create, simulate. Generative AI learns the distribution of data well enough to produce something new, including text, images, codes, music, audio, and more. So this slide marks a conceptual shift from selecting the right answer to generating a plausible new answer. Okay, so this slide is especially useful for business students because it organizes the difference in a very managerial way. Please see the table. On the left, discriminative AI or analytical AI is presented as a decision maker. Its role is automation and optimization. Its output is labels, scores, and classifications. On the right, generative AI is presented as a creator. Its role is augmentation and co-creation. Its output includes text, images, code, audio, and more. So this table tells us that the business value of AI has expanded. AI is no longer only about helping us choose better. It is increasingly about how helping us create faster, explore more options, and collaborate with machine in new ways. Now, we come to one of the most practical distinctions in this lesson. Look at the slide. On the left, we see robotic hands typing on a keyboard. On the right, we see a growing digital brain. And in the center, the slide places the contrast in two simple words: automation versus intelligence. This is a very effective metaphor. RPA is like the digital hands of the employee. It executes steps, clicks buttons, transfers data, and follows fixed procedures. AI is more like the digital brain. It learns, predicts, interprets, and supports judgment. So if you remember only one visual from this section, remember this one. RPA acts. AI learns and designs. So this slide simplifies RPA to its essence. If you look at the visual, you see a clear step-by-step flow. That is exactly the right image. Because RPA is fundamentally procedural, it moves from one step to the next according to predefined rules. So when I describe RPA in class, I often call it a robust actor. It does exactly what you tell it to do, but it does not learn from experience. It does not improve on its own. And when the environment changes unexpectedly, it usually struggles. That is why RPA is powerful but not truly intelligent in the modern AI sense. So next, this slide answers a very practical business question. Look at the balance scale in the middle. On one side, we have low cost and high speed. On the other side, we have high intelligence and high cost. This image captures the business logic of RPA extremely well. Companies use RPA widely not because it is the smartest technology, but because it is efficient, cheap, and easy to implement for standardized processes. If a task is repetitive, stable, and highly structured, RPA can often deliver strong value very quickly. So the real lesson here is that businesses' adoption is not always about the most advanced intelligence. Sometimes it is about the best cost-performance fit. This is one of the most actionable slides in the lesson. The slide uses a decision tree structure, which is exactly the right visual for this topic. Please take a look clearly. So first question, is the task standardized and repetitive? If the answer is yes, RPA is often the right choice. Second question, does the task involve unstructured data such as images or tasks or require prediction? If the answer is yes, then AI is usually the better solution. So this slide gives students a simple managerial rule. You use RPA for fixed, standardized workflows, and use AI when the tasks require learning, interpretation, or prediction. So the final content slide is very good summary because it combines theory and application in one image. On the left, we return to the Huang and Rust later. On the right, we see 3 practical questions. That layout is usually because it invites you to move from framework to diagnosis. So let's read the 3 questions as a final decision guide. If you are looking for the correct answer, then analytical or discriminative AI is usually the right colleague. If you are looking for a creative solution, then generative or intuitive AI become more relevant. If the task requires genuine empathy, then human intelligence still remains essential. So the point of this lesson is not only to memorize categories, it is to learn how to look at the task, diagnose its intelligence requirements, and match it with the right type of AI support. So that brings us to the end of lesson 2. Today, we learned that AI can be classified in different ways: by breadth of capability, by intelligence level, by functional role, and by whether it truly learns or simply automates. That gives us a much more practical understanding of what AI is doing in organizations. In the next lesson, we will go one step deeper. Once we know what kinds of AI exist, the next question is, how do these systems actually work? So in the next class, we will begin looking inside the engine of AI.